Hi there, and welcome to my second video on Newton's laws, and eponymously it's going to be Newton's second law. What is Newton's second law? Well, as I said in the previous video, it's written in Latin 300 and something years ago, so it had to be translated into English, and as such it's quite difficult to read. So I'll read it as it was translated into English by, I think, a book called Mott, I'm not sure though. So here is Newton's second law in all its glory. The alteration of motion is ever proportional to the motive force impressed, and is made in the direction of the right line in which that force is impressed. Right, so first of all, in this definition of Newton's second law, they use the word force almost interchangeably with resultant force. As explained in my previous video, resultant force is the sum of all the forces. So in this case, when we say force, we mean the resultant force, because we're assuming there are no other forces. So any force you do will be added to zero, which is the same as the force in the first place. Also, the alteration of motion, as mentioned at the start, if you think about a ball flying towards the camera, how would you change its motion? Well, you could change its motion by not throwing it as fast. So if you throw it quick, or you throw it slowly, then you have changed its motion. Its speed has changed. But I could also chuck it behind me at the same speed or at a different speed, and I will have altered its motion. So in this case, when we talk about the alteration of motion, we are talking about a change in velocity, because we could be changing the speed or we could be changing the direction. So we are talking about a change in velocity, or delta v, which will come up. Well, because in these things mass always ruins stuff, we can ignore that for a while. With a bit of mathsy fiddling, you can ignore the m and stick it back in at the end, and you come up with the change in momentum over the change in time is equal to the resultant force. And that's what we were talking about. We were talking about the resultant force being proportional to the alteration of motion. And the alteration of motion is, as we said, the change in velocity. So since mass always confuses things, we can just multiply it by mass. That's almost a constant of proportionality here. You'll probably remember in maths you used to be able to put the proportional sign. If x is proportional to y, you could put x, then the proportional sign looks like an alpha, y. Or, if you knew it was directly proportional, which these things are, you can write x equals ky. So here we can say the alteration of motion is proportional to the motive force. So F is proportional to delta V over t, which is acceleration basically, which is a change over time in velocity. And instead of the proportional sign, we can put equals k, and in this case k equals m. So as m increases, F increases directly proportionally. And since m is the constant of proportionality, this only works for constant mass systems. You can use it to approximate delta m, but it's not often used that way. So the final equation you can come up with is the change in momentum, delta mv, over the change in time, delta t, equals F. And if we times both sides by delta t, you get F delta t equals delta mv, which is also a value known as impulse. And I've done a video on momentum and impulse if you want to catch up on that. One final last thing to say about Newton's second law is, if you fiddle it a bit more, you have F equals delta mv over t. You might notice there, delta v over t, as I said before briefly, delta v over t is actually a, because the change in velocity over the change in time is just the acceleration. So you've got delta v over delta t as a, so you can actually just cancel those out and write a instead. So you're left with, instead of F equals m delta v over delta t, F equals ma. And this is commonly what we refer to as Newton's second law. If you've done mechanics, F equals ma is Newton's second law. So there are many ways to say Newton's second law, F equals ma, F equals m delta v over t, F equals delta mv over t, F equals dp by dt. They all mean the same thing. They're all to do with the resultant force affecting the acceleration of a system. I hope this video on Newton's second law has been helpful to you. Newton's third law will go up at some point. It's not as mathsy, it's more conceptual, but hopefully this has helped you and that will help you as well. And I'll try and get some links dotted around, and you can be lazy and move your mouse 3 centimeters less far than you'd otherwise have to. Thanks for watching.